a fault line, generating an earthquake. Since the 800-mile-long San Andreas Fault marks the boundary between these two tectonic plates and happens to accommodate 75% of their motion, the potential for very large buildups of energy and thus major earthquakes on this fault line exist. The two sides of the San Andreas Fault are not moving into or away from each other in a way that creates vertical motion like the vast majority of faults, but instead move in a horizontal manner where they slip past each other. In other words, while the average motion on the San Andreas Fault, which is a right lateral strike-slip fault, varies, it tends to move at an average rate of 35 mm or 1.38 inches a year. The San Andreas fault line is divided into Northern San Andreas Fault 3 segments which have varying characteristics which define them, with these being the northern segment, the central segment, and the southern segment. While one, two, or all three of these segments could technically rupture during a major earthquake, generally speaking only one segment ruptures during a large magnitude event. The northern segment stretches from just west of Cape Mendocino to the city of Hollister. It produces magnitude 7.8 plus earthquakes about once every 190 years, with these occurring in 1522, 1690, and 1906. This section of the San Andreas Fault is largely locked, meaning pressure could theoretically build up to produce a large earthquake. The good news, however, is that the last major earthquake was fairly recent. In contrast, the central section, Central San Andreas Fault, which stretches from southwest of Hollister to the town of Parkfield, is not mostly locked but is rather continuously creeping, or altogether moving at a very slow rate. This in recent times has prevented very large earthquakes from occurring here, although this segment was once the site of a magnitude 7.8 or larger earthquake at some point in the last 2,000 years, so this behavior could be a fairly recent phenomena. And we can further subdivide this segment into two regions. The northern segment has not produced any earthquakes larger than 5.5 in recent times and goes all the way to Bitterwater. However, between Bitterwater and Parkfield, especially around Parkfield, there have been fairly frequent magnitude 6.0 to 6.5 range earthquakes, and the reason for this is that some small locked sections do exist in between the creeping segments. These quakes occurred around and northwest of Parkfield every 12 to 38 years, with the last such event striking in 2004. Now for the southern segment, which stretches southern San Andreas Fault from just southeast of Parkfield all the way to Bombay Beach. This region appears to have the potential to and has produced the largest earthquakes in the entire San Andreas Fault, producing 5 magnitude 7.8 plus earthquakes between 1100 and 1857. This region marks the most likely segment to produce the big one people fear, and there are two candidate areas where this could occur. The northern region goes all the way down to Lancaster, and produces magnitude 7 plus earthquakes fairly regularly within 140 years of each other. And yet, it has been 167 years since the last major earthquake there. In contrast, there is a still high but slightly lower risk of an even larger earthquake occurring in the southern region, as it seems to produce larger magnitude events every 190 to 350 years, with the last major quake occurring all the way back in 1690, 334 years ago. Past major earthquakes in this section have been Paleolake Kauai, linked to periods when the ancient Lake Kauai was quite high, as this added additional strain on underlying faults while also sending water into gaps, lubricating fault lines and making it easier for them to slip. Yet, with only a very small and shrinking Salton Sea in recent years, the interval before the next earthquake appears to have been potentially pushed back